We are still adding, subtracting, and multiplying polynomials. This is part 2, and we're on example 5. Example 5 says, proving a polynomial identity. Prove the polynomial identity for the cube of a binomial representing a sum. So we have a plus b quantity cubed, and it says it equals a cubed plus 3a squared plus b plus 3ab squared plus b cubed. So how do we prove this? So let's take a plus b cubed, and we're going to write it as a plus b times a plus b times a plus b. Because remember, when you have something cubed, that means it's multiplied by itself 3 times. So we have a binomial times itself 3 times. If we multiply these out, like we did multiplying 3 binomials in the last video, then we should get this. And if we get this, then we have proved the polynomial identity. All right, so let's get started by multiplying the first 2 binomials together. So we have a times a, same base, add exponent, so that becomes a squared. We have a times b, so we've got plus ab. And then we have plus, or b times each of these terms. So b times a is also ab. I usually write the variable in alphabetical order if there's more than one variable. And then b times b would be b squared. All right, so that's what we get multiplying the first 2 binomials together. And we're going to bring down the last binomial as well because we haven't used it yet. Now, before we move on, let's go ahead and combine like terms. We've got a squared, we've got ab, and we've got another ab. So that's the same as plus 2ab plus b squared. That just gives us one less term to multiply by when we start multiplying by this last binomial. All right, so we have to do our first term times each term in the binomial. We have to do the middle term times each term in the binomial. And we have to do the last term times each term in the binomial. All right, so let's get started. A squared times a is a cubed. A squared times b is plus a squared b. And then we have the middle term times each of those terms. So 2ab times a would be 2a squared b. And then 2ab times b would be 2ab squared. Now we have b squared times each term in the binomial. So b squared times a is going to be, again, I like to put my variables in alphabetical order. So I'm going to put a b squared, and then b squared times b, same base, add exponents, that would be b cubed. Now we just need to combine like terms. All right, so we have a cubed. All right, and the next term we're going to have is anything that has an a squared. So we have a squared b and 2a squared b. So if there's no number here, again, remember that's a 1. 1 plus 2 is 3 a squared b's. And then here we have a b squared, and this one is a b squared as well. Again, there's no number here, so you add a 1. When there's no coefficient, you assume it to be a 1. So we've got 1 plus, or 2 plus 1 is 3 a b squared, and then b cubed. All right, now let's look up here and see what it has. So there's a cubed. We have a cubed plus 3a squared b plus 3ab squared plus b cubed. All right, so we just proved that the polynomial identity for a cube of a binomial, a plus b quantity cubed, equals this right here. Example 6, using special product patterns. All right, key idea, you have your special product patterns here, and we're going to use these formulas per se to go ahead and multiply these. So here we have a sum and difference. So it's a binomial, same binomial, different sign in the middle. So that means we're going to do a squared minus b squared. So the first term, 4n, would be your a. So we're going to do 4n squared. And then from here we say minus b squared. So we're going to have minus, and 5 would be b. And it might be easier if you put a equals 4n and b equals 5. And that way, when you're looking at this right here, you kind of know that in this case, a equals 4n and b equals 5. That way it's easier to simplify. All right, when you have 4n squared, make sure you multiply both the 4 and n by itself, because when you square it, this is in parentheses, you're squaring both the number and the variable. So it's going to be 16n squared minus, and 5 squared is 25. So to multiply these two binomials, sum and difference, this is what you would get, 16n squared minus 25, and you can see the example here as well. All right, B part, 9y minus 2 quantity squared. That fits this square of a binomial. That's a difference right here. So if it was a sum, you would use the top one. If it's a difference, you use this one. And it says it's going to be a squared minus 2ab plus b squared. So again, go ahead and identify a and b. So a is 9y and b is 2 for this example. All right, so we're going to do a squared, 9y squared minus 2 times a times b plus b squared. All right, so we're going to have 81y squared, negative 2 times 2 would be negative 4, and then times 9 would be negative 36y in the middle, and then 2 squared would be 4 on the end. All right, so to square a binomial, you're going to have a squared plus or minus, depending on what the sign is in the middle. That's the only thing that determines the sign here. It's the only difference here. 2ab plus b squared, and that will work for every binomial squared. Anytime you have a plus b quantity squared, use this formula. Anytime you have a minus b squared, use this formula. And again, this is something that is a common practice on the ACT. All right, the last one, AB plus 4 quantity cubed. So this is AB plus 4 cubed. Remember, we did A plus B, AB plus 4 times AB plus 4 times AB plus 4 is how we would have done it in a previous example. Now we can use the cube of a binomial formula and just plug it in. All right, so again, let's identify A and B. So A is going to equal AB in this case because this term is AB, and B is 4 in this case. All right, then we're just going to plug it in. So we're going to do the first term cubed, so AB cubed. And then since this is a plus, we're using the first one, so plus 3. A squared, so the first term squared, that would be AB squared, and then B. And then the next part says plus 3A, in this case is AB, and then B squared. And then the last thing would be B cubed. And in this case, B is 4, so it's going to be 4 cubed. Now we just clean it up a bit by simplifying. So AB cubed, that's the same as A cubed b cubed. We have 3 times 4, so that's 12. This is in parentheses, so a squared and b squared. Then we have 3 times ab times 4 squared. 4 squared is 16. 16 times 3 is 48, so we have 48ab. And then we have 4 cubed. 4 cubed is 4 times 4 times 4. So 4 times 4 is 16 times 4 is 64. So when you have a binomial cubed, you can use this formula right here and simplify from there. If you use these special product patterns correctly, these will give you the correct answer every single time, regardless of what your first and second term are. So in here, it uses A and B for all of these, but as you can see, A is simply the first term in the binomial and B is the second term in the binomial, and these will work for any binomial.